Today, we're diving into a secret world. It's a science that's hiding in plain sight, turning the ordinary, passive surfaces all around us into active, intelligent materials. We're talking about the incredible world of functional coatings. I mean, just take a second and look around you. The desk you're at, the phone in your hand, even the walls of the room. We think of these surfaces as just being there. They're static, kind of boring, right? But what if they weren't? What if the surface of a medical implant could actively fight off infection all on its own? Or the paint on a car could stop rust before it even starts? What if a computer chip could literally build its own perfect layers with microscopic precision? Now, this might sound like science fiction, but it's not. It's the absolutely incredible science of functional coatings. And that, right there, is the key. A functional coating isn't just a pretty layer of paint for looks. No, it's an engineered material often thinner than a human hair, designed to do a very specific job. So think less paint job and way more intelligent shield. Today, we're going to dig into 3 amazing categories: coatings that can heal, coatings that protect, and coatings that literally build our future. All right, first up, part 1, healing. Let's get into how these smart surfaces are completely changing medicine, turning simple devices into active players in keeping us healthy. So here's the fundamental problem. Anytime we put something foreign into the human body, like a catheter or an implant, we're basically rolling out the welcome mat for dangerous bacteria. This is a massive, massive challenge for hospitals all over the world. So how are scientists getting around this? Well, they've cooked up a surprisingly clever recipe. They've developed a coating that uses chitosan, a substance from shrimp and crab shells, as the little vehicle to carry the drug. The glue that makes the whole thing stick? Caffeic acid, which, believe it or not, you find in your morning coffee. And the precious cargo? A powerful antibiotic called moxifloxacin. And the result is just wow. One study found that this coating could release its antibiotic payload in a controlled, steady way for up to 49 days. Just think about that for a second. That's over a month and a half of active infection-fighting protection built right into the surface of the device itself. Incredible. But, okay, there's another catch. Medical tools have to be sterilized, right? And that often means blasting them with high-pressure steam. It's an incredibly harsh process that can just obliterate the very coatings designed to help. So how do you make a coating tough enough to actually stick around? Well, the solution wasn't about changing the chemistry, it was about changing the physics. What researchers did was use a laser to engrave a microscopic texture, like tiny little hills and valleys, onto a copper implant before applying the coating. This gave the coating thousands of little anchor points to grab onto. This super strong physical grip helps it hold on tight even after getting blasted by a harsh sterilization cycle. Okay, on to part 2, protection. We've seen how coatings can protect our bodies, but what about protecting, well, pretty much everything else? This is where functional coatings become the unsung heroes of our modern world. Let's talk about a huge, and I mean a trillion-dollar problem: corrosion, rust. It costs our global economy a fortune every single year. But just look at what a difference a coating can make. On the left, you've got an uncoated piece of metal corroding like crazy in some nasty acid. But on the right, the same exact metal, but with a new polymer coating. And the corrosion speed just plummets. We're talking 10 times lower. It's a game changer. To put a hard number on it, this coating is like an almost impenetrable barrier. It blocks over 91% of those corrosive little ions from ever even touching the metal underneath. It's a microscopic shield that has a massive impact. Now, protection isn't just about stopping rust. It can also be about repelling water. And for this, scientists look to nature, like the surface of a lotus leaf that always stays clean and dry. They came up with a simple process for a super hydrophobic coating. They use these tiny microcapsules made from tannin, yep, the same stuff in tea and wine, to create a microscopically rough surface. The result is a surface that hates water so much, any droplet that lands on it beads up into an almost perfect little sphere. We measure this with something called contact angle. Think of it this way. A flat puddle has a contact angle near 0. Well, this coating gets up to 148 degrees. That is incredibly close to being officially super hydrophobic. What that means is you get surfaces that are self-cleaning and amazingly resistant to moisture. And that brings us to our final part. And honestly, this is where things start to feel a little like science fiction. Part 3, self-assembly. We're not just applying a coating anymore.
We're now creating coatings that build themselves with unbelievable precision.
Imagine trying to build a perfectly straight wall using trillions of microscopic bricks. That's kind of the challenge when you're making surfaces for things like computer chips. One method is called spin coating. You drop a liquid full of these nanocrystals onto a spinning disc. And it turns out the secret is speed. It's all about the speed. If you spin too slowly, you get a jumbled, useless mess. But if you hit that perfect optimum speed, the physical forces actually line up all those tiny particles into these beautiful, highly ordered structures. They literally build themselves. Another really powerful tool is physical vapor deposition, or PVD. The easiest way to think about this is like 3D printing, but with individual atoms. Inside a vacuum chamber, a material is vaporized into a plasma, and then those atoms settle onto a surface, building a perfect coating one single atomic layer at a time. This gives you an insane amount of control and lets you create some of the toughest, most advanced coatings on the planet. But how in the world do you control a process that you can't even see? Well, scientists are developing these amazing diagnostic tools that let them peek inside the machine while it's running. Things like a multi-grid probe to measure the energy of the atoms as they land, or a spectrum analyzer that can actually read the light from the plasma. It's like getting a live blueprint from an atomic construction site, giving them a level of control that was just unthinkable before. So, after this whole journey from healing implants all the way to self-building materials, what's the big takeaway? Where do we land? The big idea is this. We are leaving the era where surfaces are just passive backdrops. They're becoming active players in our technology. We've seen how they can heal us by delivering drugs, protect our world by stopping corrosion, and even build our future by assembling themselves one single atom at a time. This really makes you rethink what innovation even is. Maybe the next huge breakthrough isn't some brand new device, but a new surface that makes all of our current devices smarter, tougher, and more resilient. It really leaves you wondering, now that we have the power to engineer almost any property onto any surface, what problem should we point this technology at next?